Okay, so question 5, we're given the graph m of x equals 2x minus 5 for negative 3 less than or equal to x less than or equal to 3. 5.1, determine the coordinates of k, where k is the x-intercept. So if we make a quick sketch of this diagram on our Cartesian plane, we can draw our m of x graph, which is a straight line graph, but we have a specific domain here, so we need to work out the coordinates. So if the lowest value for x is negative 3, we'll substitute that negative 3 into our m of x equation and solve for y. Y will equal to 2 into negative 3 minus 5, and we'll get the answer negative 11. So our first point for our graph will be negative 3 and negative 11. Our last point for the graph will be x is positive 3. So we'll substitute positive 3 into our m of x equation. We'll get 2 into 3 minus 5, and we'll get positive 1. So our last point for this graph will be 3 and 1. So let's determine the coordinates of k. K is the x-intercept. So the rule for the x-intercept is you make y 0. If we make y 0, we'll have 0 is equal to 2x minus 5. We solve for x there, we'll get x is equal to 5 over 2. So the coordinates of k will then be 5 over 2 and 0. Okay, 5.2 here, we're given the same graph for the same domain, and they want us here to write down the domain of the inverse graph of m. Now, it's important to understand that when they ask you for the domain of the inverse graph, it's actually the range of the original graph. So if we go to our diagram of the original graph, we'll see that our range is from negative 11 to positive 1. So the range of the original graph is negative 11 to positive 1. But here they're asking us for the domain of the inverse, which is the same as the range of the original. So our answer here should be negative 11 is less than or equal to x is less than or equal to 1, because they asked for the domain. Okay, so 5.3, let's sketch the inverse graph of m. To sketch the inverse graph of m, remember the first rule for inverse is swap x and y. So we're going to take both our coordinates, and all we do is we swap the coordinates around. So our lowest coordinate in the original was negative 3 and 11, and now it will become negative 11 and negative 3. Our highest coordinate in the original was 3 and 1, now that becomes 1 and 3. All you do is you plot those 2 points, join the graph, and that's your inverse graph. Okay, 5.4, we're given the same graph for the same domain again, but we ask now for which values of x will m of x equal to m inverse x. So for this, we need to get our m inverse graph equation. To get this equation, we take the original equation for m, which is y is equal to 2x minus 5, and for the inverse we swap x and y, so that now becomes x is equal to 2y minus 5. To get a straight line equation in standard form, we need to get it into the form y is equal to mx plus c, so we'll just sort out this equation. By taking the y over, we'll get 2y is equal to, take the x over, positive x plus 5. Y is equal to, then divide everything by 2, x over 2 plus 5 over 2. That's just basically getting it into standard form. So we have our m inverse equation, we have our m original equation. Now all we do is equate them. That's what the question wants us to do. So x over 2 plus 5 over 2 is equal to 2x minus 5. We take our x's all over onto one side, we'll get x over 2 minus 2x is equal to, we take all our constants over to the other side, negative 5 minus 5 over 2, and all we do here is we solve for x. Put your like terms together, x over 2 minus 2x will be half x minus 2, which is negative 2.5x, and that's equal to negative 7.5 on the right hand side. Divide both sides by negative 2.5, and we'll get x is equal to positive 3. Question 5, you're given m of x is equal to 2x minus 5 for negative 3 less than or equal to x less than or equal to 3. 5.5 now. If n, xy, is the point on M that is closest to the origin, calculate the distance ON. Now remember the coordinates for the origin are 0 and 0. If they want the distance ON, we need to go to our datasheet and look up the distance formula, and we'll apply the distance formula to these 2 points, O and N, where O is the origin 0, 0, and N is the point X and Y. So from the datasheet, we'll get ON squared is equal to X minus 0 all squared plus Y minus 0 all squared. That's your distance formula. And we simplify this equation, we'll get ON squared is equal to X squared plus Y squared. Now, it's important to remember here that when you're given an equation of a graph in Y form, you can use the Y value there. In this case, m of x is equal to 2x minus 5, which means y is equal to 2x minus 5, which means that instead of y, we can write 2x minus 5. So into this ON squared equation, instead of y, we will substitute 2x minus 5. So we'll end up with ON squared is equal to x squared plus 2x minus 5 all squared. So we open this up algebraically, square the binomial there, so we'll end up with x squared plus 4x squared minus 20x plus 25. Put your like terms together, you'll end up with ON squared equals 5x squared plus, minus 20x plus 25. And if they want you to find a distance at the closest or lowest or nearest or highest or maximum or minimum, all those terms mean find derivative. So we're going to find the derivative of this distance formula that we have here. So ON prime will equal to, the derivative there will be 10x minus 20. We take that derivative, make it equal to 0 and solve for x. We'll get our x value is 2. To get the distance then, we take that x value of 2, substitute into our distance formula for x. We can calculate y as well, substitute the y in as well, and you'll get your final answer for the distance. You can calculate that easily. Okay, 5.6, given m of x is equal to 2x minus 5 for negative 3 less than or equal to x less than or equal to 3 again. 5.6 now, given m of x is equal to f prime x, where f is a function defined for x between negative 3 and 3. Explain why f has a local minimum. Okay, so now they gave us that m of x is the derivative of f, where f is the original graph. So if our derivative graph is m of x, which is a straight line graph, it means that our original graph will be a parabola. So we can work out approximately what our original graph equation will be by finding the antiderivative of m of x. So we'll get f of x, the original graph, is equal to x squared minus 5x plus c. If we find the derivative here of our f of x graph, we'll end up with 2x minus 5, which is our derivative graph, m of x there. So as we can see, our f of x graph now, the x squared is positive. It means that from y is equal to ax squared plus bx plus c, which is the standard form of the parabola, a is greater than 0. If a is greater than 0, it means that the graph is a happy face graph. And if the graph is a happy face graph for the parabola, it means that the graph has a minimum value at the bottom there. Okay, again, 5.6, given m of x equals to f prime x, where f is a function defined for the same domain, what is the maximum gradient of the tangent to the graph of the tangent to the graph of f? So the gradient of f is the same as the derivative of f, which is f prime. Now, we did work out, well, we do know what the derivative is for the graph of f. It's the m of x equation that was given to us. So now if we want the maximum gradient, the maximum value for x is 3. So we'll substitute that 3 into our m of x equation, and we'll get m at 3, which is equal to 2 into 3 minus 5, and that's equal to 1.